Hi, let's talk about linear equations. So a linear equation is the equation of a line. So you'll see it written in a couple of different ways. You'll see y is equal to mx plus b. And so the components of this are the y value, m is the slope, which I'll explain in just a second, the x value, and the y-intercept. So a linear equation describes the graph of a line. So a line on the xy axis might look something like this. So the slope is the measure of how steep that line is. So if the line is perfectly horizontal, it'll have a slope of 0. And I'm talking about left to right. If it gets steeper as you move from the left to the right, then the slope increases. As it approaches a vertical line, the slope approaches infinity. And then if a perfectly vertical line has an undefined slope. So one way you'll see the equation of a line written as y equals mx plus b. Another way you'll see it written is ax, a is some number, plus by, where b is some other number, is equal to c. And this is another way to write the equation of a line, but it's perfectly equivalent to y equals mx plus b. It's just written, it's kind of more general. But you can see that it's the same thing, because if I took this equation, ax plus by equals c, and if I just subtract ax from both sides, now I'm left with by is equal to negative a times x plus c. And then if I divide both sides by b, then I have y is equal to negative a over b times x plus c over b. And since I never specified what a is and what b is and what c is, for simplicity's sake, let's say that none of them are 0, so that for example, so I can divide by b. But they're just numbers, and so if a and b are kind of undetermined numbers, then negative a divided by b is also kind of an undetermined number. And so you can think of this as the slope. This is the slope. And this is the y-intercept. So instead of m, let me put slope. And so if you have to, you can go back and forth between y equals mx plus b and ax plus by equals c, those two equations of a line. For example, in your homework probably you'll see lots of examples that look like ax plus by equals c, and the question will be find the slope. So the first thing you want to do is solve it for y, like I did here, so that you can see the coefficient of x, and the coefficient of x will be the slope. So let's plot some lines based on their graphs. Let's plot some lines. So 3x plus y equals 1. If I'm looking at the equation of a line, if I'm looking at the graph of a line, I only really need to know a couple of things to be able to draw it. I need to know where it crosses the y-axis. That's the y-intercept, which is here. That's where it intercepts the y-axis. And so similarly, there's an x-intercept, which is where it intercepts the x-axis. But usually all you need to know are two things. You need to know the y-intercept and the slope. So the y-intercept is where it crosses the y-axis. And if you notice on the x-axis, the y-axis crosses the x-axis at 0. This is the point in 0, 0. So in order to find the y-intercept, and I could either have the slope of the equation of the line y equals mx plus b, or I could have ax plus by equals c. It doesn't matter. To find the y-intercept, I need to know the value of y when x is equal to 0. So all I got to do is set x equal to 0. So let's do that. So I need two things. The slope and the y-intercept. So an easy way to find the slope is if it were written in the form y equals mx plus b, then it would just be m. I don't have that immediately, but it's not that hard to get. All I got to do is subtract the 3x. So let me write this again. So I'm going to subtract 3x on both sides, of course. And so on the left, I just have y. And on the right, I have, and let me put the negative 3x first. So it looks more like y equals mx plus b. And so m is the coefficient of x. That's everything that's multiplying the x. So in this case, it's negative 3. And the y-intercept. So to find the y-intercept, again, I set x equal to 0. And I could do that in this equation, or I could do that in my original equation. Either one is fine. And either one looks just as easy. So let's just use the original one. So in the original equation, actually, if you're not sure which one to use, it might be good to use the original one, just in case you there was some algebra mistake when you derived the form y equals mx plus b. Then you won't be carrying that mistake over with you when you find the y-intercept. So let's just start again with the original information we have, which is 3x plus y equals 1. And then I'm going to set x equal to 0, so I have 3 times 0 plus y equals 1. And 3 times 0 is 0, so I just get y equals 1. So that's my y-intercept. And now I've got the slope, and I've got the y-intercept, so I should be able to draw this line. So let's get some xy axes going here. So there's x and there's y. Let's put a few numbers on this number line. So it starts at 0. Here's 1, 2, 3, and 4. And on the y-axis, 1, 2, 3, and 4. So let's see, the y-intercept is y equals 1. So the y-axis, the line is going to intercept the y-axis at y equals 1. So that's right here. So if you think about it, there's infinitely many lines that could go through this point here with the y-intercept y equals 1. you could have a horizontal line, you could have one with a 45 angle slope, which is the slope of 1, or a super steep line, or maybe even a vertical line. But there are infinitely many, and the thing that makes it unique, or the thing that determines which specific line you have, is your other piece of information, which is the slope. So the slope is -3. If you want to think about that as a ratio, that's -3 over 1. So the change in y is -3 and the change in x is 1. So if I start at the point that I know, the change in x is 1, so I'll go 1 over, and the change in y is -3. So maybe I should put some marks on the bottom of this y-axis. So -1, -2, -3, -4. So I'm going to start at the point that I know, and the slope is -3, so that's down 3 over 1. The change in y is -3, and the change in x is 1. So I'm going to go down 3, down 1, 2, 3, and over 1. And then I can, so that's all I really need if I'm good at sketching, but I might as well plot a few points just so that it looks nice. So down 1, 2, 3, and over 1. Now if I want to go the other way, I'm not allowed to change the slope, but I can write it so that it looks different. If I were to take the slope -3 over 1 and multiply it by, let's say I multiply it by 1. If you multiply a number by 1, that doesn't change the number, right? So what if I multiplied by -1 over -1? Because -1 divided by -1 is 1, so I'm really just multiplying it by 1. So on the top here I get 3, and on the bottom I get -1. So this is just another way to write -3 and a different ratio with different numbers. But if you think about it now, if you think about it in terms of the slope, now the change in y is 3 and the change in x is -1. So now if I were to start at this point on the y-axis, and let me draw some negative x values. I think these numbers are going to get in the way. I'm just going to move them to the other side. So this is 1, 2, 3, 4. Now I can put -1 and -2 here. So in blue, I'm going to start at this point. My new way of thinking of the slope is change in y is 3, change in x is -1. So I go 1 to the left and 3 up. 1, 2, 3. And you can see it falls in line with the other ones. So I'm going to go ahead and draw the most perfect line you've ever seen. Nice. So this is the equation of the line 3, or this is the graph of the line 3x plus y equals 1. Now let's say that you graphed this line, you did a bunch of algebra, and you think you're right, and you just want to check your work. Here is a way that you can check your work. This equation, 3x plus y equals 1, it has 2 variables. That means if you plug in those 2 variables, you should get it's called a tautology. If you get something like 1 equals 1 or 2 equals 2, that's called a tautology. So if I were to just pick an easy point on the graph that I know to be true, like this point at 1, -2. This point is at 1, -2. So if I were to plug that in to this equation, x is 1 plus y, and y is -2, and that's equal to 1. I'm just going to put a little question mark here because I'm not saying that's true. I'm saying that's what I hope is true if I did my work correctly. So that's what I'm checking. So 3 times 1 is, let me just put a line here. 3 times 1 is 3. And then plus negative 2 is minus 2. And is that equal to 1? Yes, that's equal to 1. 3 minus 2 is 1. 1 is equal to 1. Check. So just to check your work a little bit there. So the plot is here. That's a line with a large negative slope. It's going steeply down from left to right. And you can see it's y-intercept that we found. And you could even find that x-intercept. Do we want to find the x-intercept just for practice? Let's see, I'll fit it in here. So think about the x-intercept. What does it mean? The x-intercept is the place where the line intercepts the x-axis. So let's look for the x-axis here. The x-axis is this horizontal axis. The determining characteristic of the x-axis is that all the y values are 0 there. So to find the x-intercept, the x-intercept being the place where the line intercepts the x-axis, and the property of all the points on the x-axis is that the y values are 0, then to find the x-intercept, you would want to set y equal to 0. So the original equation is 3x plus y, and y is 0. And that's equal to 1. So 3x equals 1. So x equals 1/3. And so that's another thing you can do to check your work. Find the x-intercept, even though they didn't ask for it, and then look at your graph and make sure it makes sense. Does it look like my line is crossing the x-intercept, the x-axis, at x equals 1/3? So here's 1 and here's 0. And that line is a little bit to the left of where 1/2 would be, so it's not perfect, but it's good enough. I like it. So it just gives me more confidence that my answer is correct. Thanks for watching. If you thought it was helpful, click the like button. Be sure to subscribe to get more videos like this in the future. And if you have any questions on what we covered today, leave them in the comments below. For Dr. Smith's math class, this is Dr. Smith. Class dismissed.